The .NET framework is composed of three components: the CTS, the CLR, and the CLS. So the CTS, we have looked at the CTS. We said the CTS, it's basically a list of types that are supported by the framework. The CLR is basically the runtime component of the .NET framework. So it has the responsibility that has anything to do with code execution. So, but before we look at how the CLR works, or what are the responsibilities of the CLR, first understand that what is a type. A type is basically a definition of how a certain form of data should be presented in memory. The main reason we write software application is because we want to process data. For example, you could be writing a software application that is going to process a set of numbers. Numbers themselves come in different forms. There are integer numbers, numbers without fractions, and there are floating point numbers, numbers with fractions. So integer numbers themselves can also be subcategorized into short integers and long integers. So depending on the range of integers that you want the application to process, and the floating point numbers can also be subcategorized into single floating point numbers and double floating point numbers, depending on the range of numbers with fraction that you want your application to process. Other forms of data that are other simple forms of data that our application are processing include string literals. String literals is basically data that can be presented using the letters. There are date time to present the dates and years. There are characters to present a single character. So basically, there are different forms of data that are the data that our application processes comes in different forms. So in order for our application for the computer to be able to differentiate between these forms of data, there has to be a definition of each and every form of data, so that the computer is able to allocate a memory for each form of data that it's going to process, and to be able to differentiate between amongst these different forms of data. The CTS basically has the list of these definition of different forms of data, and that include integers, strings, date times, that include double. There are other complex forms of data that are included in the CTS. So, for example, there are types to actually present an XML document. So it's a bit more complex to present an XML document in memory than it is to present a simple data such as integers or floating point numbers. So a type is basically a definition of how a certain form of data should be presented in memory. So the CLR has the responsibility of code execution. So this definition of data has properties. One has properties such as the amount of space that is going to be required to process that form of data that your application will be processing. For example, if you're working with integer numbers, so when you are working with integer numbers, in order for the CLR to allocate enough space to store an integer number, there has to be a definition within the definition of the integer type. There is a property that specifies the minimum and the maximum value. So therefore, using those values, the CLR is able to allocate enough space to be able to store the integers that your application will be processing. Does that make sense? Yeah. CLR has the responsibilities that have anything to do with code execution, thread coordination, application hosting, performing security checks to ensure that you are actually allowing a, a code that is coming from a trusted source in your computer. So when, for example, when you have installed an application in Windows, you probably have noticed that you are getting a message before your application is installed. You are getting a warning message that this application, it's going to make changes in your hard drives. That means it's going to delete files, it's going to create files, it's going to have access to all the files that are within your computer. So so that application should be coming from a trusted source. So that message is coming from the CLR component of the .NET framework. So now let's look at how this is actually happening under the hood. So we say CLR, it's the runtime component of the .NET framework, and it has the responsibilities that involve code execution. CLR, it's basically an abbreviation, né, which stands for Common Language Runtime. This is an abbreviation for the CLR. So we say it has the responsibilities such as performing security checks on the code to be executed. Perform security checks. To ensure that you are allowing the code that is coming from a trusted source to make changes within your computer. It also does application hosting. When you are basically writing an application targeting the .NET framework, your application, it's not going to be hosted by the operating system to which it will be executing. It will be hosted by this component of the .NET framework. The third one would be to actually thread coordination. The CLR is the one that creates and destroy or delete threads, thread coordination, threads of your application. So these are basically few of the responsibilities of the CLR component. There's actually a huge list of responsibilities of the CLR component. So here I was just listing these ones just to give you an idea or highlight on what basically this component does. So now let's look at how all this happens. So let's say you are writing an application in C#. You are writing an application in C#. When you write an application in any in any language, you are basically making use of text editors such as Notepad, Visual Studio, or any text editor that you'll be using to write your code. And you will be writing your code within those text editors following the syntax of the language that you will be using to write your code. So there's your code in C# following the C# syntax. So after you write your code here is in the human readable text. It basically follows the language that you will be using, the syntax of the language that you will be using. In this case, we are using C#. So then there's a part, or there's a program that is responsible for taking your human readable application to convert it to a binary form, because that's what computers actually understand. They understand binary data. So that part of that program, it's called a compiler. So C# has a compiler. Each language has a compiler. So the compiler is going to take your human readable text and convert it to produce what we call an assembly. An assembly is a file which will take this file extension .dll or .exe, so depending on the type of application that you will be that you'll be writing. If you are writing a class library, your assembly is going to take the .dll file extension. But if you are writing an executable application, your file is going to take this, the .exe file extension. So we're not going to go into details with this type of application. But basically, you write your code in using any of the text editors, following the syntax of the language that you will be using, and then your code is going to be compiled to produce an assembly. And we say an assembly is a file that will take any of these file extension, depending on the type of application that you will be writing. So what is within this file? What is within this file? It's basically not a set of instructions that are platform specific. It's not a set of instructions that are platform specific. It's basically a set of instructions that are platform agnostic. That means they are not specific. So what is going to happen, the CLR, it's going to take whatever is within these files and convert it to platform specific, depending on where your application will be executing. For example, if your application will be executing in a computer that is making use of Intel, then the CLR is going to take this set of instructions within these files and convert them to a set of instructions that are going to be understood by the Intel microprocessor. If your application is running within a computer which has the AMD microprocessor, the CLR is going to take the set of instructions within this file and convert it to a set of instructions that is going to be understood by the AMD microprocessor. But the set of instructions within these files, it's not platform specific. That means they are not compiled to execute to any platform. It's just a set of instructions that are understood, that can be understood by the CLR. So the set of instructions of your program within these files are basically called CLI, Common Language Intermediate. Yeah, the CLI. So there's a part of, within this component, there's another component called JIT, Just-in-Time Compiler. The Just-in-Time Compiler, which is basically a subcomponent, that is within the CLR component, is going to take these CLI, the Common Language Intermediate, and convert them to platform specific, depending on where your application would be executing. Does that make sense? So we can go into details. We can say a lot about how this is happening. Here I was just giving you a highlight of basically how your application gets to be executed from where you are typing your code to where the CLR is going to convert this set of instructions and execute them. Does that make sense? So next, on our next video, we're going to look into the practicals of how this happens. Till next time.